Well, hello there. I'm going to go ahead and cover what I did in the workshop tonight on February 17th. I'm sorry that two of you couldn't make it, but hopefully you'll have a chance to get the code here for what we did. We worked on the tank movement script. Um, so to get that tank movement script open up, you'd want to have your project opened up and click on the scripts folder. And then from the scripts folder, you can open that up with that little gray triangle there. Click on the tank folder and double click the tank movement script. If you'll remember, this tank movement script, we already applied it to our tank. And we even set some stuff up. We set up the audio sources, linked them all up. And in our last session, we also talked a little about this script. I went over what Unity Engine is and the public variables that we see here. And we also see those very same public variables over in Unity right here listed in the tank movement script because they're part of the script. So we also talked about these private variables, and these are the variables we're going to be working with here. In fact, remember, we'll be working with all of these variables. We'll be using them all in the script that we're going to create here. Remind you about the rigid body. This is the component that we added to the tank. The rigid body is right here. This is what allows us to apply physics to it. It has all these fields that we're allowed to affect. And we're able to apply force to this as well. So over here in the tank movement script, we're going to start in the update method. Now, in the last session, I also talked to you about what these initial functions do. And then we got down to this point. And so what I recommend you do is click your mouse so that your mouse is at the end of that comment right there. And I want you to look at these curly braces here above and below that comment line. Those curly braces are part of the private void update. Don't break those curly braces. So what I always do is I always, inside the curly braces, give myself about 3 lines of space while I'm coding inside of a function. And then I'll put my mouse right back up there on that line right after the store the player's input and make sure audio for engine is playing. And we're going to go ahead and start typing. Now, one really cool thing about Visual Studio, notice I typed M underbar, and there's a bunch of choices there. In fact, I already see the choice I want. I can use my down arrow on my keyboard here and go down to M underbar movement input value, and then I can press my enter key, and Visual Studio will type it for me. So that's one of our variables. We want to get information from the computer system. So we're going to let that be equal to, and I'll type IN, and this suggestion, it's called Intellisense. Intellisense is suggesting, hey, I think you want to type the command input, and it's right. I'll press the enter key and let it type it for me. Then I'll press my period here, and Intellisense is already suggesting to me, hey, do you want get axis? And yes, I do. I want get axis. So I'm going to hit that button. Now, at this point, I'll put these parentheses in here. I have to tell the input.getAxis. I have to tell it what axis I want it to get. Then it's going to get information from that axis, and input will pass that to the M movement input value, this variable right here. So the axis we're going to get here is the M underbar movement axis name. Now here I clicked it with my mouse. In fact, if you double click it, it'll type it for you on a double click. So there we go. First line of code done. This last character, this semicolon right here, is called the terminator. The terminator right there, that little character, the terminator. It terminates a line of code. Cassidy said, it acts like a period on a sentence. And he's right. It is. Periods mark the end of a sentence. Terminator marks the end of a line of executable code. All right. Now, we also need to get the turn input. So I'm going to type M underbar T, and now my choices are turn axis, turn input, turn speed. I want turn input value. So we also need to know if the tank's going to be turning. This tank is moved by WASD. W and S is the movement axis name. A and D is going to be the turn axis name. It's going to be equal to, again, input dot get axis. And this time it'll be M underbar turn axis name. And I typed it, and I know I typed it fast because Intellisense just makes that possible. It makes it possible for me to move at a higher rate of speed. Now, from here, I will take out the extra lines I have there, although we're going to come back a little bit later, and we are actually going to add one more line of code right there. So I'll leave that all ready for that other line of code we're going to add. So that's our update method for right now. All right. Now, from the update method now, we're going to take these two values and we're going to head down to the move and turn methods. But first, we're going to make a detour right here at fixed update. So, fixed update. What's the difference between update and fixed update? Okay, because here they got the same word update, but one's update and one's fixed update. Well, update, you can read right here when I mouse over this. It's called every frame of the game. And the game will run at about 60 frames a second. So every frame update gets called. Fixed update, on the other hand, fixed update is called every fixed frame rate frame. And that's confusing language for fixed update is called whenever we want to apply physics to any object in the scene. So when we make our tank move, we are applying physics. So that's the point in time that we're going to be calling fixed update, because we're going to be using physics in order to make the tank move. But fixed update's got two very simple lines of code, because actually fixed update is not doing all the work. All fixed update is going to do is call the move function. And then it's also going to call the turn function. And the move and the turn functions, they're actually going to be what handles making the tank move and making the tank turn. So I'll type move, open and close parenthesis, terminator, and that is a function call to the move function. And I'll type TU, and it already is suggesting turn with a capital T. And I will put the parentheses on with the terminator, and there we go. We're calling the move function, calling the turn function, and now we're going to come down here and add the code to the move function, and we're going to add the code to the turn function. And tank move and turn. Now, to make the tank move, we're going to be using a vector 3. Vectors have force and they have magnitude, direction and magnitude. Hopefully those words might mean something to you. Direction should mean something to you. Vectors tell me what direction do I want to go in. Magnitude, force, tells me how much force do I want to exert to go in that direction. So in a vector 3, in its essence, it contains three values. It contains an x, a y, and a z value of where the tank needs to move to based on the vector. So this vector 3, we're going to give it a name. Right now, it doesn't exist. All that Intellisense is picking up on is MOVEMENT. Well, now it is going to exist. In just a minute, when I type MOV, it's going to suggest that to me. It didn't exist before, but now it does. This is a user-defined variable. We're the user. We're the coder. We're defining this variable, and it's going to be called movement. And it's going to be equal to type TR, and what I want is that lowercase transform, TR with the lowercase. Notice there's also an uppercase transform. These are two different commands. So I want the one with the lowercase t. And then it's forward, transform.forward. There we go. And so this is basically it's a fancy way of saying along the x-axis, the transforms forward. wherever the local x-axis is, that's where the front of the transform for the z-axis is. Z-axis, the positive z-axis, is always pointing towards forward. If we look at it over here in Unity on our tank, you'll notice that that blue stick, that is the z-axis. That z-axis is pointed in the forward direction. As the tank's driving around, if I were to get into play mode just for a second here, and it's not moving yet. Yeah, well, in a little bit. When it's moving around, you'll see that blue stick it'll keep pointing in the direction. Yeah, well, we have some code we need to finish writing here if we want this thing to move. So let's keep this going. We're going to multiply that value, and because that is a numerical value, we can multiply it by our m underbar movement input value, and we're also going to multiply that by our m underbar speed, m underbar speed. And the last thing we're going to multiply it by, this is going to be a little strange the first time you see it. It's called time dot delta time. What time dot delta time is time dot delta time is Unity Engine's way of actually not making the tank move every single frame, because if it did, it would move incredibly fast. You could take this out later if you wanted to. You could take that out. In fact, maybe I will just for experimental purposes to show you. If time dot delta time, if we don't multiply by time dot delta time, the tank will be zipping around so fast and it will have no way of controlling its speed. Time dot delta time slows everything down. And then next we're going to then take this movement vector and we're going to apply this movement vector to the rigid body of the tank. So that M underbar rigid body, we're going to go dot move position. And we have to tell it where we want it to go. So it'll be the M underbar rigid body dot position. And we're going to add to that. Notice now movement exists. I typed MOV and there it is. It's right down there. It didn't exist before when I first typed it, but after I typed it and I defined it and created this variable, this vector3 variable, now it appears in Intellisense. That's a intelligent editor there. I like that. In the old days, we did not have such wonderful things as Intellisense that would practically code the code for us. Now, this is a point where we can actually make something happen. If you save your script, and I did it by clicking this little save symbol right here, you can also click File, Save Assets, Scripts, TankMovement.cs. You could click that. You could also click File, Save All. That's like the hammer, the sledgehammer. Just save everything. At the moment, there's only one thing to save, but later we're going to have 3, 4, 5, 6 different scripts opened up, because this game is run by 6 different scripts, 7 different scripts. It's quite a few. So now, back in Unity, Unity's got that fact that something changed, and so it's updating itself. It's getting this new information we added to the tank movement script compiled and ready to execute. And I'll press the play button here now. And if I press the W key and the S key, there I'm pressing W, and I press the S key, I'm now moving forward and backwards. Uh-oh. I'm going to have to figure that out. I've seen it at school. I can drive into the building. All right. So tank moves forward and backwards. Now let's make it turn. And then we're going to do that in the turn function. So again, I'm going to click right here. Give me some space. I need space. And my turn function here, I'm going to start off by defining a variable that'll be a float. Float means a number with a decimal point. And this float's going to be called turn. It didn't exist before I typed that, but going forward, it will exist. And it'll be equal to this is going to be a similar line of code to what we saw up there when we set up this vector3 movement. It involved multiplying by the movement input value, and down here, we're going to take the turn input value now, and we're going to multiply this by the m underbar turn speed, and lastly multiply by my good friend time dot delta time to slow things down. Now, this variable then needs to be passed into something called a quaternion. A quaternion is it is an object that's used to handle rotations. So by typing QUAT brings quaternion to the top, and I'm going to call this one turn rotation. Notice here at this moment the system doesn't recognize turn rotation, but going forward it will recognize turn rotation because I just created it. And it's going to be equal to a quaternion dot Euler. Now, Euler was a German mathematician. I believe he lived over 100 years ago. He was famous in his time, and a lot of the mathematics that he developed contributed to the development of computer science. And so he gets something named after him. And this quaternion gets three values passed into it. It's the rotation in X, the rotation in Y, and the rotation in Z. We don't want to be rotating in X. Anyway, we froze it, but we're going to still put it in at 0. Here we're going to put that turn, that float turn that we got. This is telling us how many degrees do I want to rotate in Y. I'm either going to be rotating a positive number of degrees or a negative number of degrees in Y, depending on whether I pressed A or D. A throws a -1, D throws a +1, so that turn input value will make the value of turn positive for D and negative for A, and we'll rotate according to the number of degrees that are calculated. And then, of course, for Z, we also want to be rotating 0F. And then the last line of code here is where we apply this turn rotation quaternion. Now we apply this to the rigid body. So M underbar rigid body dot, and be careful, before we did move position, but this time we're going to do move rotation. And the move rotation will be not equal. Move rotation, we'll have an open parenthesis here. And we'll pass in the M underbar rigid body. But this time, before we were accessing the position up there. We were accessing the position. But this time, we're dealing with rotations. Notice there's rotation right there. I don't even have to type an R. I can just double click it and it'll type it for me. And I want to multiply that rotation by my turn rotation. And so now, about that coded up, I'm going to go ahead and click my save button right here and go back to Unity. Unity has picked up on the fact that I made changes to the script. It's saving itself. I'm going to click File, Save. Hey, save early, save often. And now I'll hit the play button and see what happens. I can turn, and I can disappear. And I've disappeared. I can't find myself. There we go, found myself. So this is how to drive the tanks game at this point. Okay, now, I said something earlier. Let me turn my tank is selected here. Okay, I got my tank selected. And there's a little button up here called Global. Global, this is the X, Y, and Z axis in the world. I'm going to switch that to local. Local. This is the X, Y, and Z axis as it relates to the tank. And watch as I rotate here. You see that Z axis is rotating now? When it was on global and I rotate, it doesn't rotate. But when I switch that to local and I rotate, now, oops, I deselected my tank. Now, that tank rotates. You can see that. So whatever direction that Z-axis is pointing in, that's the direction the tank is going to go driving off in now. All depends on where that Z-axis is pointing. All right. So now, as we're driving, all we're ever hearing is our idling sound. So the next thing we're going to do here is we're going to turn on the proper audio. So this line of code is so long, it goes right off the screen. So I'm just going to turn it into another comment. And then I'm going to put those lines, the space in. Don't break these curly braces here. This is the engine audio function. It needs to be called. I'm going to Control C, copy that, and just paste it right there. And it needs to be called every frame. So I'm going to put it in the update function. So every frame, I'm going to call the engine audio function. And the engine audio function, it's going to play the correct audio clip based on whether or not the tank is moving and what audio is currently playing. So in general, if the tank is moving, I should be playing the engine driving audio. And then if I stop, it should switch to the engine idling. And if I start to move again or turn, it should play the engine driving, and so on. So depending on whether the tank is moving, engine driving, or stopped, engine idling, it'll be setting the correct audio. All right. So engine audio function. This one's a beast. So it's going to consist of an if statement with an if statement inside of it, followed by an else statement. This first if is going to be looking to see, is the tank stopped? So the way that I check if the tank is stopped, I'm looking to see if, and then we're going to be using a function called mathf. These are the math function library. So there's a lot of math functions in computer science. So I'm going to type MAT, and let's see, there it is right down there. Mathf, the math functions, dot, and it's brought it right up there at the top. ABS, absolute value. It's alphabetical. That's what I want. I'm looking to see if the absolute value of my M underbar move input value, is that number like close to 0? Is it less than 0.1 F? And I want to look to see if my mathf dot absolute value of my M underbar turn input value, I want to look to see if that is less than 0.1 F. And if either of those values, well, in this case, it can't be if either. If both of those values are close to 0, if the absolute value of both of those values is close to 0, then the tank is not supposed to be moving. Nobody's pressing W, A, S, or D. No key is being pressed. So we want to make sure. So I hit the enter key, and I'm going to put an opening curly brace. So these curly braces, and I'll hit my enter key here. These curly braces, this opening and closing curly brace, it will contain all the executable code for this if statement. So if this is true, I need to look and check for something. Is the engine driving audio playing? If so, change to engine idling. It's a nice little comment there to explain what it is that I'm doing. So if M underbar M movement audio, if M underbar movement audio dot clip, if the clip that is currently playing, and I'm going to use what's called the comparison operator, the double equal sign, the comparison operator. I want to compare the clip that's currently playing with a clip that I know about, which is called M underbar engine driving. So, if the tanks come to a stop, I need to stop that engine driving audio if it is playing. Hit the enter key and set up the curly braces for this if statement. So look in here now. You should see that you've got these parent curly braces for the whole engine audio function. See how this one's blue and that one up there went blue too? Then you have this curly brace, which has its mate right there for this if statement. So this is this parent if statement that has inside of it a nested if statement. And now inside of there, we're going to add some code. M underbar movement audio dot clip equals M underbar engine idling. So we want to change the clip that we currently want to have play. We also want to change the pitch of that clip. You might remember that, looking here in Unity on the audio source has a field called pitch, has a variable called pitch that could be affected. And in our script, we have this variable called pitch range of 0.2f. So with that pitch range of 0.2f, that means that we're going to vary our pitch between 0.8 and 1.2. So any time I switch audio, if I go from driving to idling or from idling to driving, I'm going to be changing the pitch every time. And this little bit of code will make that happen. It just makes for a better audio effect to not always have it be the same pitch. That variety adds something to the game. Aesthetics are important. So now we're going to affect the movement audio dot, be careful, pitch. See, before we were changing the clip, our movement audio over here, not this first one, but the second one, because this is the one that the script is. Yeah. So there's a clip here, the audio clip. That is what M underbar movement audio dot clip is referring to. This dot pitch is referring to that pitch field. This is going to be equal to a random dot range. Now, random range, basically we need to give it a lowest possible value and a largest possible value. So we're going to start with our original pitch, which is M underbar original pitch, and we're going to subtract from that our M underbar, start all over again, M underbar pitch range. There we go. So that's going to be the low possible value. And then a clever person might jump in here and just don't copy the comma, but copy that part, paste it, and change the subtraction to addition. So the original pitch subtract the pitch range is the lowest value. The original pitch plus the pitch range is the largest value. So like I said, 0.8 to 1.2. And then at the end of this line of code, don't forget it, because it's off the end there, put your terminator on. You should have a terminator right there. Lastly, we need to tell that M underbar movement audio to play. And this code's ready to do its job. So if I'm driving and the driving clip is playing, if I stop and the driving clip is playing, it's going to switch to engine idling and it's going to play that. And so first part's done. Now I want to get at the end of this if. We're only going to get in here if we're not moving. If we're not moving in any frame, if we're not moving, then it's going to hop in here and make sure that we're playing the right audio. Now, if we're already playing engine idling, it'll skip this because that'll be false. It won't do this stuff. The right clip will already be playing. So, but after this, we need to check so, is the tank driving? If so, play the driving audio. This is going to involve the else. And I'll put my open and close curly brace right here. If this if statement is true, it's going to do this and skip the else. However, if the if statement, if either one of these is false, I'm either moving or I'm turning. If I'm moving or I'm turning, then it's going to skip the if and it's going to go right to the else. And it's going to make sure that it's playing the driving audio. Now, the great thing about this is I get to steal this code right here. I get to steal this code. I'm going to change 4 things, but I get to steal it all from the beginning of this comment to the closing curly brace of this inner if. I'm just going to copy it all. Come down here, hop in the else, and I'm going to paste it. And everywhere I see engine driving, I'm going to change it to idling. And everywhere I see engine idling, I'm going to change it to driving. And especially, that's important right down here. If my audio clip currently playing is idling, then I want to make sure that I have the engine driving clip playing. So I changed the comment here, engine idling. If engine idling audio is playing, if so, change to engine driving. So I'm checking if the movement audio clip is engine idling, then I set the clip to engine driving, put that pitch at a new random pitch range. Wasn't it nice to have that just copied for us? And then tell it to play. So now let's click our save the script button there and then go back to Unity. Unity's picking up on the fact that more changes have come in. And now I'm going to zoom just a little bit out so I can see my tank move around and tilt a little sideways here. And I'm going to hit this play button and let's see how things go. Notice that pitch change. All right, that's working. Make sure that you save, go file save your Unity scene. I always recommend that, I see students at school do this all the time. They shut their machine down without properly closing Visual Studio. Some of them have lost their code. You're going to be responsible and you're going to close Visual Studio and see it close. And you've saved your Unity scene and you're done messing around with it. Close Unity and see Unity close. Okay? And we're done for today. I'll see you on Thursday. I'll see you on Tuesday. Have a great weekend. Thank you so much.